We're working on 3.2 today. Hopefully, most of this is review. So here I have, hang on a second. Here I have a difference of perfect squares. So 7 minus 5z and 7 plus 5z. Okay. What if it was a plus inside there? Would 7 plus 5z and 7 plus 5z work? No. Because the middle term wouldn't cancel, right? So in this form, that is 35z, and this is negative 35z, so the middle term is 0. But if I put a plus there, now the middle term exists. What if they're both minus? Would that work? No. So if it's a plus, then you have i's. It would be 7 plus 5zi and 7, or, well, this would be minus. 7 minus 5zi and 7 plus 5zi. Okay. Next one. So here, this looks a lot like x squared minus 4x minus 12. And that would factor into x minus 6 and x plus 2. But if I put a y squared and a y here, how does that change it? It would just be x minus 6y and x plus 2y. Crazy. All right, here is a difference of squares with two variables. 9z minus 5x and 9z plus 5x. Am I going too fast? This should be review from last year. Okay. No, that's why we're reviewing it. All right, how do we factor with a... I broke it. How do we factor a quadratic where the leading coefficient is negative? Well, we really don't want to. So I'm going to pull out a negative. So negative, and then I just yank a negative out of everything. 2w squared plus, oops, that would be minus 11w plus 21. And then this one, can I pull the 2 out without creating fractions? No, so we need to use the box. So in the box, I put in 2w squared and 21. Multiply those together. 42w squared. Are there factors of 42 that add to be negative 11? So 1 and 42, does that work? No. 2 and 21, does that work? No. 3 and 14, that's it. So it would be 3w and negative 14w. So the top row shares a w, and that gives me 2w plus 3. Pull out a 2w here. So the end result is negative 2w plus 3 and w minus 7. Now, if you don't like that negative out front, you can distribute it into either of those fractions. If I put it in here, I would end up with 2 negatives. So I would probably want to put it in there. And I get 2w plus 3. And then we don't like to lead with a negative, so this could be 7 minus w. Although this and this are exactly the same. So either one of those will work. Whose car alarm's going off? You figured out whose it was? Oh. Okay, this one, we're just going to use the box to factor. So I put 3v squared negative 72. Oh, I don't even know what that is. So 72 times 3 is 216. And it's negative. And I need factors of 216 that add to be 15. So 216 divided by 6 is 36. That's not it. 216 divided by 9 is 24. That's what I want. So negative 9v and 24v. So I pull out a 3 and a v, and I get v minus, not w, v minus 3. And then I pull out a v, and I get, why is there a w in there? Oh, that's not a, boy, I am all over the place today. So, v minus 3 and 3v plus 24, but notice I can take a 3 out of that. So 3 times v minus 3 times v minus plus 8. So I could have taken a 3 out of the beginning, but I wasn't paying attention. Hey, there it is again. Okay, next. So, what do 18 and negative 50v share? A 2. So pull out a 2, and I get 9 minus 25v squared. So that would be 2 times 3 minus 25v and 3 plus 25v. And again, remember, in order for that to work, this has to be a negative. If that is a positive, then you would put i's over there. We're going to see a lot of that this year. Okay, this might be one you don't remember, or maybe you haven't seen before. Factor by grouping. So this is a cubic equation. You guys are very proficient at solving or factoring quadratic equations. Now, cubic equations, there are a whole bunch of different types, and each type factors a little bit differently. And I really only know 2 or 3 types, okay? And this one happens to be the easiest. So if you see a cubic equation and it asks you to factor, we're going to do what is called factor by grouping. Otherwise, we're pretty much just not going to do cubics. Well, we are, but we're going to do something different. So factor by grouping says we look at the first 2 factors and the second 2 factors and see what each group has in common. So what does the first group have in common? U squared. So we pull out a u squared, and what's left? 3u plus 2. Okay? And now what does the second group share? A 5, and then I get 3u plus 2. Now, if factor by grouping is a possibility, then this will match that. If not, then it doesn't factor by grouping, and you have to use another method. And I never even learned those methods because there's an easier way. No, I don't know if it's easier, but there's a different way that we use. So, what does this term share with that term? They both have a 3u plus 2, right? So I'm going to yank the 3u plus 2 out. So I write 3u plus 2, and what's left? U squared plus 5. And that is the factored form. Now it is possible that that is going to factor further. Does that one factor further? it's a plus, so it has imaginary roots. So, and it wouldn't be 2.5, it would be root 5. It would be u plus I root 5 and u minus I root 5, but we don't need to do that. All right. Oh, that one I'm going to, well, so here is the other cubic equation. So if you have the sum of two cubes, it factors into a plus b and then a squared minus ab plus b squared. If you have the difference of two cubes, a to the third minus b to the third would be a minus b and a squared plus ab plus b. Okay, so this one, a is 2 and b is x. So it would be 2 plus x, and then 2 squared is 4 minus 2x plus x squared. Because it's a to the third plus b to the third. So that would be 2 to the third plus x to the third. Okay, you might see one of these questions on the ACT. So what if I had x squared minus 27? Not squared, third. So that would be x to the third minus 3 to the third. So that would be x minus 3 times x squared plus 3x plus 9. And all you really have to remember is that this sign goes there and the opposite sign goes there. So if I were to change this to x to the third plus 3 to the third, then this would become a plus and this would become a minus. Okay? So I guess that's the other cubic equation that you might see. All right, here is another grouping. What does the first one share? The first two share? Nothing. So I'm just going to pull out a 1. 3y squared minus 4w. And then what does the second one share? Just a y. So plus y, and then I get negative 12y. Okay, so I'm going to negative 12, thank you. Plus w. Do those match? No, but could I rearrange it in such a way that it would match? Yeah. So what if I did 3y squared plus yw minus 12y minus 4w? Now, what do those share? A y. So 3y plus w. What do these share? A negative 4. Negative 4 times 3y plus w. Now I can group them. Yank that out. So 3y plus w. And what's left? Y minus 4. So that one we had to do a little bit of thinking to group things together the right way. Okay. I guess in general, if nothing comes out, well, usually if nothing comes out, you need to reorder them. That's not entirely true, but it's probably true most of the time. All right. Okay. So here I can pull out a u to the fourth. That leaves me with a 2u to the fourth. That leaves me with 16 minus w to the fourth. Okay? Uh-oh, he's on his phone. You taking pictures? That's okay. New term, new citizenship. This is a difference of perfect squares. So 2u to the fourth, and this would be 4 minus w squared and 4 plus w squared. You see that? But this is also a difference of perfect squares. So 2u to the fourth, and then 2 minus w, 2 plus w, and then 4 plus w squared. And again, you could factor this using i's, but it doesn't want us to. All right, and lastly, I'm going to move the 64 over. X to the fourth minus 20x squared plus 64. Are there factors of 64 that add to be 20? So 1 and 64, that doesn't work. 2 and 32, that doesn't work. 4 and 16. So this is sort of a quadratic equation. The difference is instead of x minus 4 and x minus 16, it's going to be x squared minus 4. So x squared minus 4 and x squared minus 16. Will either of those factor any further? Both of them. X minus 2 and x plus 2, x minus 4 and x plus 4. All right, that is it for 3.2.